things is just comparing real numbers. So we kind of did that on the previous slide, just saying where would it fall in between. This time what they're going to do is they're going to be asking us to compare or identify which one is greater. So here it says which is greater, the square root of 5 or 2 3/4. So the first thing is to understand where would the square root of 5 fall. So kind of doing what we just previously did, square root of 4 and then the square root of 9. It's pretty close to 4, right? Because square root of 5 would just be one number difference. So that's why they identified it here. Now, if you would like to use a calculator for this part, I would be okay with that. I think they still want you approximating the squares. Okay, so now if I were to look on the number line, well, which is bigger? Are 2 3/4. Or if they ask us to compare, it would be like that if they had them with an open space between it. Okay, so let's practice some of these. Once again, approximating those roots, paying attention to symbols. Okay, which is greater, 0.6 repeating or the square root of 0.36. So square root of 0.36, if you want to go through and use your calculator for that, it's okay. This is the same as 0.6. So if they were to ask us, and I think on your worksheet it asks you to compare them like this, and that's repeating. Okay, which is bigger? Well, this is the same as 0.66, and this is the same as 0.60. So now which is bigger? The repeating number is bigger. So anytime you have digits that are the same and one's repeating, the repeating number is bigger, unless they throw a negative sign in there. So 0.6 repeating is bigger than the square root of 0.36. So you're going to solve first for those square roots and then go from there. Okay, so square root of 23 is really close to square root of 25. So this one's really close to 5 on the number line. And this is going to be closer to 4 on the number line. So which is going to be bigger? The square root of 23. And if I want to check that, I could change both of them to decimals too. 23, the square root is 4.79. And 4 1/5 is 4.2. So once again, if you prefer to see them as a decimal, you could also compare them that way. Okay, so comparing again, which number is greater, the square root of 10 versus the negative square root of 5. So here they're giving us two square roots that are not perfect. Okay, the first thing I look at here is I'm noticing there's a negative in front of this one. I don't even have to convert these into their decimal or anything or approximate them. I know that the smaller number is the negative. So if I were comparing this and I had this written out like this, and then comparing to the negative square root of 5, that negative is already making it smaller, so my open mouth would go that way. Or the square root of 10 is greater than the negative square root of 5. Okay, so I want you to try this one. You have the negative square root of 2, and then compare that to 2. Which one is greater? Key thing to remember on this one is you are working negative numbers. So remember that negative sign out in the front means the opposite. So normally, if I was just comparing these as whole numbers, I would say that the 2 is bigger than the square root of 2 because that's obviously going to be like 1.4 or something like that with a long number. Okay, so you have to remember because you're working negative numbers, the bigger the digit, the less it's worth. So which is greater? Our negative square root of 2 is actually greater because it's in the negative set of the category. It's actually closer to 0. If I was looking at my 0 line, here's negative 2, and negative square root of 2 would be like at 1.4 if this was 1. Okay, negative 1.4, this would be my square root of negative, or my negative square root of 2. Okay, so it's bigger because it's closer to 0. Or not closer to 0, but further down the line on the right side. Okay, so that's working with comparing